There are two mRNA COVID-19 vaccines currently available, Moderna and Pfizer BioNTech. When a COVID-19 mRNA vaccine is injected into your arm, and thanks to the lipid nanoparticles in which they are encased, the fragile and negatively charged mRNA strands find their way into your cells without being degraded by the environment or your body. Once inside a cell's cytoplasm, they bind to ribosomes, which are formed of rRNA and proteins, and are these cellular machines that produce proteins in our bodies. Starting from the 5' untranslated region, which consists of codons that will not be translated, the ribosome scans the mRNA and starts translation at the first start codon, AUG, it finds. The ribosome attracts transfer RNA. These tRNA carry anticodons in sets of 3 nucleotides and a corresponding amino acid. If the anticodon complements the codon in the mRNA being read by the ribosome, then the amino acid from the charged tRNA is added to the amino acid chain and the tRNA is released by the ribosome. When we say charged tRNA, this refers to tRNA that has undergone tRNA charging, where a matching amino acid is attached to its 3' end, whereas uncharged tRNA has no amino acid attached. During the elongation stage of translation, the ribosome adds amino acids to the amino acid chain in the order they are read off the mRNA. The amino acids, in the exact order they are translated in, produces a unique protein with a unique shape. In this case, the result is a spike protein that looks just like the ones found on the COVID-19 virus. You can see now where the spike protein gets its name. At some point, the ribosomes will reach the stop codon on the mRNA, which no tRNA will recognize, and the ribosome will stop translating the mRNA and adding new amino acids to the chain. In other words, elongation ceases. The 3' untranslated region that immediately follows the stop codon is not translated, but it is nonetheless critical to the stability of the messenger RNA. So now our own cells are producing these spike proteins, and when our immune cells run into them, they learn to recognize and destroy them. Like a punching bag training our immune cells, these spike proteins prepare us in the case of a real COVID-19 attack. But will the vaccine still work if COVID-19 mutates? In the case of synonymous mutations in the codons are silent, so there is no change to the amino acids that go into building the spike protein. Consequently, the spike protein will look the same, and our immune system will be able to recognize it from the punching bag spike proteins just as before. If, however, there are mutations in the RNA of the new COVID-19 strains such that the spike protein is built with a different set of amino acids, then the resulting protein will be a different shape, and we need to redesign the mRNA in the vaccine so that our ribosomes can produce the new spike protein and recognize them on the new strain of mutated COVID-19 virus.